Okay, next. In this video, we are going to learn common tangents. Okay, common tangents. Okay. So, when you have two circles, okay, may it be same size or different size, okay, so actually you can draw several tangents which touches the circle, each of the circle at only a point. Okay, so for example, this circle and this circle, so I can draw this tangent. You see, this tangent is very magic because this tangent, it is not only the tangent for this small circle which touches the small circle at this point, but this straight line also touches the big circle at only a point here. So this line is actually the common tangents of the small circle and also the big circle. Okay, so as for another one also, this is also another common tangent. Okay, that contact point is here and also here. Okay, are you clear? So this is common tangent. So it means that for this diagram, we have two common tangents. We can draw two common tangents here. Okay, how about this one? The circles are connected to each other, touching each other. So there's only one common tangent. Okay, this straight line, we can say that it is a tangent to this big circle, or we can also say that this straight line is also a tangent to the small circle, because this straight line touches the circle, each of the circle at only a point. This straight line touches the small circle at this point, and this straight line also touches this circle at the contact point here. So this straight line is actually the common tangents of the two circles. Okay, or maybe the circles are inside the small circle inside the big circle. Okay, so this one also having one common tangents only, okay, which is here. Okay, so for this type of common tangents, we call it common internal tangents. Okay, common internal tangents. Okay, next. As for these two circles, okay, if we draw the tangent from outside here, we can also have two. Okay, we have two. Maybe you say, teacher, just now we also got two. Why not we combine it? You can combine it if the question didn't mention about internal or external. Okay, so for this one is internal one. This one is external one. If the question didn't mention about internal or external, they only ask common tangents, then you can draw out the four. Okay, two external, two internal. So we have four. Okay, so as for the notes here, I want to split it because I want you to recognize which one is internal and which one is external. Okay, so this one only one. Okay, so this is common external tangents. Clear? Okay, so maybe if the question didn't mention about this, okay, draw the common tangents of this circle. So how many actually? Apart from this one, we can also have this one and this one, right? So we can have three actually. Okay, so it depends on how the question asks. Alright, okay, so let's look at this example. Example 16. Tell how many common tangents the circles have and draw them. The question didn't mention about internal or external, so you can go with both. Okay, so for question A, how many common tangents do you think it have? It has. Okay, 1, 2, 3, right? How about this one? 1, 2, right? How about this one? Only one. Let's see the answer. Okay, so this one 3 common tangents, this one 2 tangents, this one 1 common tangent. Okay, clear? Remember what is tangent? Tangent is a straight line that will touch the circle at only a point. So when it is regarding common tangents, so it refers to a straight line that will touches each of the circle at only a point. Okay, clear? All right. Okay, so for this one, we will continue it with the next video. Okay, angle between tangent and chord. So I hope you know already what is chord, what is tangent. Okay, so let's look at this one. This line is the tangent, and these two are actually the chord. This one actually also the chord. So what can we say about the angle between the tangent and the chord? This angle. Okay, this angle is actually between this tangent and also this chord, right? So there's an angle here. So this angle is actually equal to this angle. And the angle between this tangent and the chord here, which is A, is actually equal to this A. Okay, so the angle formed by tangent and the chord, which passes through the points of tangency, is actually equal to the angle in the alternate segment. Okay, which is subtended by the chord. Okay, this is the chord. So you need to go like this. I will show you later, okay, in the example. Okay, example 17. Okay, let's look at this question. Find the value of x and y. Okay, so you need to know what can I use to find my x. Okay, you say, oh teacher, to find x, I need to know what is my y. Oh teacher, this y probably is 60. Are you sure? Why 60? Can I say this is alternate segment since this is not parallel? The question didn't mention about that they are parallel. This line is not parallel to this line. So you cannot just simply conclude that this is alternate angle and they are equal. No, unless the question tell you that it is. But this is not. Okay? So you need to find another method to get the answer. How can I find my x? So you say, oh teacher, I see that this is tangent and then this is chord. So I remember back, you told me before, the angle between tangent and chord, right? So this angle is actually equals to this angle. Okay, why? How do we get it? Okay, I will show you a very simple way to help you to recognize the angles that are equal. Okay, so this is tangent, this one tangent, and then the green one is the chord. So this is the angle, 60 degree is the angle between the chord and the tangent. So this angle is actually probably equals to another angle inside the triangle, right? So you have to use your 2 finger, okay? You make it on your chord, and then using the root of the triangle, okay, inside the circle, you go to the same destination. You go it like this. Only when you go like this, you will reach one destination, one same destination, right? Okay. Okay, this angle, 60 degree, is actually equals to this one. So x is equal to 60 degree. Okay, clear? Okay, how about y? Y. Okay, again, this is tangent. This is the chord. Okay, so this angle, the angle between the chord and also the tangent, is actually equals to another angle inside the triangle, right? So, as I told you, you need to use your 2 finger, point it on the chord that form up this angle, okay, and then you go to the same direction, okay? So you go like this, and you will reach the same destination here. So this angle is actually equal to this angle. So y is actually equal to this angle. So I can say that this is also y. So how do you get the y here? You need to use angle on a straight line, which is 180, right? Minus 60 minus 40. Okay, so the answer will be 80 degree. Okay. Okay. Example 18 will be the last example. Actually, this example we have been discussed before, but we use different method because we haven't learned angle between chord and tangent. Since we already learned it a few minutes before, okay, so now we will apply what we have learned to get the answer. You can check it back later, the one that we have discussed before with the different method. You can check it again. You will see that the answer is actually equal. Okay, so now the question. I forgot to copy and paste the question. Actually, the question is wanting you to find x and y. Okay, so in order to get x, okay, I need to look at the angle subtended at the center here. Okay, and I will look at the isosceles triangle. Okay, so 180 minus 140, I will get 20 degree. Okay, so this angle is actually 20 degree. Okay. So, you see, why I find 20 degree just now? Because actually I know that the angle x is actually, you see here, we look back. Okay, angle x is actually the angle formed by the tangent and also the chord here. Right? So this angle is actually equals to angle ABC. Okay, you see I go like this. So x is actually equals to these two angles. So it is not enough for me to only have 40. I need to know what is this angle. Only then when I sum up I will get my x. That's why I need to use this one to get the 20. Okay, so the answer for x will be 40 plus 20, which is 60 degree. Okay, next. To find y. Okay, to find y, I need to know this angle. Why? Okay, let me find this angle first. Okay, this is angle subtended at the center, right? 140 degree because it is subtended by the RAB with these two radius at the center. Okay, and then there are two chords also subtended by this common arc. So this angle is actually half of this. Or we can say that this is actually twice of this. So in order to get this one, we divide this one with 2. Okay, so angle ACB is equal to 140 divided by 2, which is 70 degree. Okay, so once I get this 70 degree, okay, actually it is equal to y. You know why? Because y is actually the angle formed from the tangent and also the chord here. So when we fly from the chord here to one same destination, it is actually equals to this angle. Okay? So y is equal to this angle. What did you get just now for this? 70. So conclusion, y is equal to 70 degree. Okay? Alright, that's all.